Here we're going to build upon our knowledge of vectors, where a vector is a quantity with both magnitude and direction, and we're going to have a look at how we can combine multiple vectors to find out the overall sum of them. We're just going to look at perpendicular vectors for now. We'll look at others at arbitrary angles a little further down the line. So let's look at displacement vectors. Let's say we're travelling along the ground, and we're going to start off by travelling north 700 meters. And after travelling north, we're then going to travel in another direction. So this is our first displacement, 700 meters north, and then we're going to travel east. And you can see this is perpendicular to our initial northward direction. Let's say we're going east 500 meters. So obviously this is not to scale. And we want to know what's the overall vector that we've travelled. So we want to know, having gone from here up to here, how can we describe this vector that we've just drawn in red? Our overall vector, the sum of these two perpendicular vectors. And we can see here what we've got is the long side of a right angled triangle. So to find the sum of two perpendicular vectors, we just need to use Pythagoras' theorem. So in this case, that means if I label this side x, then in order to find the side x, so the length of our vector, and then we'll come on to the direction later, in order to find the length of this vector, x squared is equal to 700 squared plus 500 squared. So x is equal to the square root of 700 squared plus 500 squared. And if we punch that into a calculator, you'll see that we get 860 meters. So we can see this length x is 860 meters. We've described the magnitude, but this is a vector we're describing. The sum of these two vectors gives us another vector. So we've got the magnitude, now we need to work out what its direction is. And we can describe the direction in one of two ways. The simplest is going to be describing how far east of north it is, and so that's going to be this angle, which we can label as theta. Alternatively, we might decide to describe how far north of east it is, so this angle. But we'll stick with this inside angle for now. The difference is quite trivial, it just changes which trigonometric function we use. So we can see we've got this theta here, and we're going to use trigonometry to find out what size it is. So compared to this theta, this side is our adjacent, this is our opposite, and this is our hypotenuse. So if we go through our little SOHCAHTOA mantra, we know the adjacent and the hypotenuse, but we also know the adjacent and the opposite, but we also know the hypotenuse. However, the hypotenuse we've just calculated ourselves. So rather than using the hypotenuse, where we might have made a mistake which would then carry through, we're going to stick to using the opposite and the adjacent which we were provided with. And we can see if we've got the opposite and the adjacent, it means we're going to use the tan function. So the tan of our angle theta is equal to opposite over adjacent, which in this case is going to give us 500 over 700. And that means that in order to get theta, that's going to be the inverse tan of our 500 over 700. And if you put that into your calculator, then you'll find you get about 35.5 degrees. So this angle theta here, we've just found out to be our 35.5 degrees, and the magnitude is 860 meters. So we're able to fully describe this vector x by its magnitude, the 860, and its direction, 35.5 degrees east of north. So this angle we've described accurately, we've managed to calculate that. So this is how, when we've got two perpendicular vectors such as north and east, or south and west, or more typically vertical and horizontal vectors, we can combine them to work out what their net is, work out what their summed equivalent is. So this x at 860 meters and 35 degrees east of north is equivalent to these two individual vectors that we've taken in order to make it up. So the 700 north combined with the 500 east is exactly equivalent to having just gone our 860 meters at 35 degrees east of north.